Hello and welcome back to the third lesson in this Java tutorial series. In today's lesson, we're going to be discussing the idea of modifying information. So, if you'll remember, in the first lesson, we talked about the importance of three things in coding. This idea of storing information, this idea of modifying information, and this idea of sharing information. In the first lesson, we talked about the importance of storing information, being able to store information for later use in these like containers or variables is the other word for it. Um, but in this lesson, I want to discuss the importance and the how-tos for modifying information. All right, so the first thing that I want to talk about here is the different kinds of math operations we can do. This is the first idea of modifying information is being able to do some kind of mathematical operation. And so we're just going to go down the list and kind of look at the ones that we have access to for most numbers. The first is addition, which calculates the sum of two numbers. Subtraction, the difference between two numbers. We have this symbol, which represents multiplication, and this will give us the product between two numbers. Division, just a forward slash, and this will give us the quotient between two numbers. It is important to note that there is two different types of division, and it depends on which types of data you are doing division between. If you have two integers, what's going to happen is it's going to do something called integer division. And what this is just going to do is it's going to do the division, and whatever is left over, say you have like 10 divided by 3, giving you 3.33333. What it's going to do is it's going to just cut off the decimal and leave everything else there. It's just going to give you a whole number, and that is what it would be called integer division. The alternative is if either of your two numbers that you are doing division between are doubles or floats, or they're just decimal numbers, then it's going to do decimal division, where it just calculates out a long, precise answer for your quotient there. The last one I want to talk about real quickly is modulus. If you think back to third grade mathematics, third or fourth grade, but before we knew about fractions and decimals, there was this idea of the remainder when doing division. So say you had like 10 divided by 3, because we don't know what decimals are or fractions are, the answer for that would be 3 with a remainder of 1 for 10 divided by 3. And that's what this modulus does, is it calculates the remainder when we're doing division. So this is something that you'll kind of see is really important to certain calculations, but it's just important to know that it exists. So just another example, 5 modulus 2 would equal 1 here, because 5 divided by 2 is 4 with a remainder of 1, and we're calculating the remainder. So actually moving on to this idea of modifying information, we're going to look back to something we learned about in our first lesson. In our first lesson, we had this process of assignment, declaration, and initialization. And so the first part of that was assignment, where we store a value in our container. And the way we did this was through the use of an equal signs, or an equal sign. But that equal sign is actually more powerful than just storing an initial value. That equal sign can basically rewrite whatever is currently stored in our container. So if we created a container that stored some random data type, and the name of our container was just label here, and it stored some item in it, if we were to have another line of code later that would list label equals new item, what it's going to do is it's going to take the current value stored in our container, and it's going to just get rid of that value and store this new value in here. And that is what this equal sign does. And I talked about this in the first lesson of how it's not like your basic math operation equal sign. It's this idea of storing a new value in your container. So just looking at this equal sign operation again in action, we're going to look at an example here in Java. So if I create an integer container and I label that container an integer, and I store the value of 5 in it, then if I print it out, system.out.println, and I print out an an integer, and I run it, you'll see I get the result down here 5, exactly as we expected. The statement's going to go and look inside of our container, and it's going to look for the value stored in there. It's going to print it out. But if we then go an integer equals 15, what happens is this process that I have drawn here is it's going to take the value that's currently stored in there with the value of 5, and it's going to get rid of it, and it's going to store this new value of 15. So now every time we reference this container labeled an integer, it's going to now refer to this value of 15. So now if I print it out again, you'll now see that we get the value of 15 here. Up until now, I've kind of represented all of our information with these labels of an integer, a string, to kind of help you get the idea down for how the syntax works for each of these like different variables. But the real value in the way this is all set up is that the name of our data that we're storing is extremely useful more as an idea than it is the number that's stored inside of it. So from now on, for a lot of my examples, I'm going to start renaming all of these the labels on our containers to represent actual ideas, because this is when coding starts to make like a lot more sense, because you can start representing your ideas in code through this like process kind of visualization. So then let's take a look at this example here using the number of puppies in my household. So I'm going to create an integer container that stores the number of puppies in my household, and at the moment there is one puppy in my household. So we're going to go int num puppies equals 1, and what I want to represent is the idea that, okay, I have one puppy in my household, but I know in the future that I'm going to want 2 dogs for my dog to be very social with. So I might as well get 2 more puppies for my household. And so what we want to do is we want to update this this container storing the number of puppies in my household with the addition of 2 more puppies. Now, what we could do if I print this out, system.println number of puppies. If I print this out, it'll store it'll print out the value of 1, and say, well, I know I have 1 puppy in my household. If I have 2 more, well, I can just say there's 3, and I mean that'll print out the right answer. But as our code gets more complicated, what we want to do is we don't want to rewrite the information. We want to modify it, and so using a combination of these operators that we were talking about earlier, like addition, subtraction, multiplication, etc., and this equal signs, where the equals sign will reassign the current value stored in our container, we want to update the value or the number of puppies in my household based off of the number of puppies that are already here. So if I go back to the original example where I only have 1 dog in my household, then what we can do is we can look at the statement over here of kind of how to set this up. And so I'll kind of walk through this in a sec here. Number of puppies equals number of puppies plus 2. And so the way to interpret what's going on here is we're modifying the information that is stored in our number of puppies container, but we're doing that by using the information that's already present. So how Java interprets this is it takes the current value of the number of puppies in my house, it pulls it out of our container, and then it does the addition here. So 1 plus 2 will store the value of 3, or it'll calculate out to the value of 3, and then it is going to then at the very end store the result back in the number of puppies, and it's going to reassign the value in number of puppies as 3, which you can kind of see here. So if we run the code here, we now still have the same result. And so this is an extremely important idea where we've been able to modify the information without having to rewrite it. So that brings us to the end of the more lecture heavy part of our lesson. I encourage you to go over and try the quiz over here. If you want it to run, just a quick reminder, you just hit run Java and answer each of the corresponding letters. If it was A, you'd put an A, and it'll correct you. It'll tell you why you're wrong, and I encourage you to go through this and just make sure you understand why the answers are the way they are here. Then, once you're done with the quiz and you're confident in all of your answers and your reasoning behind them, we have two exercises over here to expand on our knowledge here. And so, or just to give us some practice. So, looking at the area of a trapezoid, we know that it is side length A times side length B divided by 2 multiplied by the height. And so it is going to be your job here to use each of these different variables here, these containers, to create a calculator to calculate the area of our trapezoid. And what you're going to want to do is you're going to want to store that in a container labeled area that stores a double value. So that way, when we run this program, it will look for a container labeled area and then print out the resulting calculation for the area of our trapezoid calculator. The second exercise that we have here is just a really simple physics problem that calculates the average miles per hour. And this one's a little bit harder than the last, but it is still very doable. Now, with both of these exercises, I highly encourage you to go and try these on your own. Try to get these to run on your own and calculating the correct answer, because learning really comes from doing these things yourself. Me just sitting here yapping at you for half an hour, it'll get some of the ideas across, but the real value in all of these lessons really comes from you putting in the work and trying to think through these processes yourself. That's when you're going to really learn the most. So I'm gonna pause. I encourage you to pause the video here and come back and look at the solutions once you've given it a shot yourself and seen if you're able to do this or not. So now that we've finished the trapezoid area calculator, the next thing we're going to do is figure out how to kind of solve this physics problem. And the importance of this problem is not to show that you can perform some kind of calculation, but it's just to get you into this mindset of thinking with the tools that you have. Because coding is very different from writing on a notebook. You have completely new tools at your disposal, and there's a different way of kind of solving problems that you would normally have a certain process for, by maybe solving it out by hand. But there's kind of a different thought process here when we're coding, because we have so many more tools. So the one real quick disclaimer here is that this problem is a little tricky in the fact that average speed is not the average speed between the two parts of the trip that you were on. So if during the first half you went 100 miles per hour for a tenth of a second, and the second half you went 60 miles per hour um, for say 24 hours, then the average speed that you went during the trip would be way closer to 60 miles per hour than it would be the 100 miles per hour, because it depends. If you kind of think about it logically, the time that you spent going really fast was for such a short period of time that it doesn't really affect the average. So we need to calculate the average, not by taking the average of the two, but by taking the total distance divided by the total time here. So that's the one thing to be wary of when solving this problem. So when I solve problems like this, my thought process is I like to just map out all of the information that I'm given here at the beginning of this problem. So you went on a trip that was divided into two parts. In the first part, you traveled 60 miles in 1 hour. So the first thing I want to grab here is the distance that we went during the first half, because at some point we want to calculate the total distance. And so we're going to create a variable here. We're going to create a container that's going to store this idea for how far we went during the first half. So double first half distance first half. We'll do that. Distance first half is what we'll name it. And this follows the naming convention of our variables being very concise and representing this idea of what we want stored in it. It doesn't matter what numbers are associated with it. We want this variable to represent the idea. And so here, I'll just kind of keep going, and it'll make more sense as we go through this. So the distance of the first half is 60 miles per hour. And then we had that second piece of information, which was how long we were on the first half of the trip for. Double time first half, and that's going to equal 1 hour. So the second part of this, in the second part, which was also 60 miles, so we'll write that down. Double distance second half equals 60. And then, but you traveled 20% faster than the first part. And so I'm going to add another comment here real quick. Speed equals distance divided by time. And I have it written down here, or written somewhere else around here. But it's just nice to have with like a little formulas sheet right there. But the speed, we went 20% faster than the first part. And so what you'll actually notice is we weren't given the speed for the first part, but we can calculate the speed. So we can do speed equals distance divided by time. So if I go down here, double speed first half equals the distance during the first half divided by the time of the first half. So distance first half divided by time first half. And we can calculate the speed here. And so now that we know the speed of the first half, we can calculate the speed of the second half, since we went 20% faster for the second part. So we'll do that. Double speed second half equals speed first half times 1.2, and that's just the increase by 20% there. Alright, so calculate the overall average speed. And we go back to our original formula here with the average speed is equal to the total distance divided by the total time. So how about we take a look at the variables that we have here. We have the distance for the first half, and if I look through this, we also have the distance for the second half. So we could actually calculate one of these values here for the average speed that we went on. So how about we do that? We'll calculate the total distance. Double total distance equals distance first half plus the distance second half. And so now that we have that, the only thing we have left to solve for with the average speed is the total time here. And so how do we solve for time? And we can do that by rearranging this simple equation. If we want to solve for time, it would be the same as distance divided by speed. If you treat this as like an algebraic equation, and you divide both sides by distance, or if you multiply both sides by time and then divide both sides by speed, you'll get time equals distance divided by speed. So, and you can actually see that formula right here, as I have it as a hint here. So what we're going to want to do here is we're going to want to calculate the time for the second half using that rearrangement of the formula. So we're going to create a value we're going to create a number to store this information. So double, I'll add an extra space here, double time second half equals the distance divided by the speed, which is just right here. So the distance of the second half divided by the speed of the second half equals distance of the second half divided by the speed of the second half. Alright, and now looking through the information that we have here, we have the time of the second half, and we have the time of the first half. So with that, we should be able to calculate the total time. So if we go double time, or total time, total, can't capitalize correctly, total time equals time first half plus the time of the second half. And now this is kind of like unorganized, but it more follows like the thought process. But we have all of these variables representing the different pieces of information that we've been looking through here. And if I were to write this out on a piece of paper, this would actually this would kind of be like a lot more difficult because I would actually have to go through and actually solve each of these by hand. But because this is a computer, we can just have this be treated as a calculation. And the benefit of that is that all of like this thought process here is more based on the ideas of solving the problem rather than having to like get all nitty gritty with the numbers. And so now that we have the total distance and the total time, we can use these two to calculate the average speed. So we'll do that real quickly. Double average speed equals total distance divided by the total time. All right, and so with that, we've actually solved the problem, and we can just print this out to see what the answer is. System.out. Oops, yeah, print ln, and we're gonna just put average speed in there. And so if we run this, we get the result of 65.45 miles per hour, which is the correct answer for this problem. And had you done it differently, doing the just reiterating this again, if you had done it not using the total distance divided by the total time, you actually would have gotten a different answer where mostly just because it's the idea of what you were doing was technically like wrong. So alright, so that brings us to the end of this lesson. If you were struggling with that last exercise, it is a little complicated, but I encourage you to go back and watch it again if something didn't make sense. What is important isn't the physics part of it, it's more the thought process of, okay, so I see these problems, how do I represent this information? How do I go about performing these calculations? And that's more what's important. Then rather than solving the problem, the way you abstract ideas to these variables rather than doing like the hard calculations with numbers and just representing my or your thoughts through the process of variables rather than numbers. So but just as a quick recap, in this lesson we covered a few things. We went through how to modify information using like addition, subtraction, uh, as well as learning about the modulus operator. We also learned about how the equal signs work, or the equals sign works, and how it modifies the information stored in our variables or our containers. And then we learned a little bit about combining strings together to make our statements more readable. So if you have any comments, please leave them down below, and we'll see you in the next one. All right, see ya.